certain type of investment, bank account, whatever. It's a certain type of savings plan that is a little bit more complex than your traditional, I put in $10,000 and that grew by this percentage, compounded this often, how much is the account worth in 20 years kind of thing. It's a little bit a lot more complex than that. Do you remember that formula? Final amount equals initial amount 1 plus R over N to the NT power. That's just basic compound interest. That's if you put a certain dollar amount in, how much will it grow to at a certain rate over a certain amount of time, compounded at a certain frequency. The difference between that, and there are some similarities. You can kind of see the 1 plus R over N to the NT power that's in there. There are some similarities, but it's a little bit more complex because it's not just you put in money, you leave it there, and you touch it 20 years later. An annuity is when you put in, it's like a savings plan, and you put in a certain dollar amount on a certain frequency basis. Like you put in $100 a month. So not only is if you put in $100 a month, if you just waited a year, the $100 you put in January, that would earn interest 12 times, right? But then you're putting in a $100 in February, and that would earn interest 11 times. And then you would add, you keep adding your own contribution, and then every subsequent month, that particular deposit has a less percentage. So there's like 12 mini deposits, and they're all earning interest kind of one less time than the one before that. So it creates a more complex formula. You don't have to memorize that formula. I will give you that. But P stands for the recurring deposit, R for the percent annual interest, so as a decimal, just like we've done before. N is your number of times compounded per year. T is your number of years. And the capital A is the final value of the annuity. So to save for retirement, and this is how most savings plans are, right? I'm going to assume, well, I don't know, but when you save for retirement, usually you just get stuff taken out on a monthly basis, or even a twice a month basis, because you get bi-weekly paychecks typically. When people save for college, when your family saves for college for you guys, I'm going to guess they don't just, well, maybe, depends on the situation, I guess, but I'm going to assume they just decide, okay, we're going to put $200 a month in for our kid, and then do it that way, just so it's recurring, and they don't think about it, and it just happens naturally. So this particular example, to save for retirement, you deposit $1,000 per month. So what variable does that stand for, Marissa? P. Into a 401k for the next 30 years. Where's the 30 go? Sarah? T. If the interest rate is 5%, what does that give us, Abby? So R equals what? Good. And the money is compounded monthly. Andrew, what's that give us? N equals, yeah, so what number? 12 for monthly. Good. How much is the annuity going to be worth after 30 years? So one thing that it's great to see your accounts grow. But what you have to differentiate is why it's growing partially because you keep adding money to it. And it's more fun and exciting to see how much money you're gaining for free, right? So if we just did, and we're just talking principal deposits, pretending we were going to make nothing. If you just did $1,000 per month, $1,000 per month, so 1,000 times 12, for 30 years, you will have on your own saved up $360,000, okay? What's going to be more exciting is our final account balance, to know, hey, only $360,000 of that was my money. The rest of that was actually somebody else's money, right? So we really are more interested usually in the growth that we get. So if the interest rate, so we just start plugging in. So the final value of the annuity is, I'm gonna work on the left here because I might want to do something fun in a minute. The final value of the account is, your P is your 1,000, brackets, parentheses, 1 plus 0.05 over 12 to the 12 times 30th power minus 1, close your bracket, all over a fraction, R over N, which is 0.05 over 12. And then it's just crunching numbers in your calculator. So as much as you can, I would try to do this all in one shot. So I would do my 1,000, open parentheses, open a second set of parentheses, 1 plus 0.05 divided by 12, close that parentheses, raise it to the, now my calculator uses the caret, so if I hit 12 times 30 right now, it's going to raise it to the 12th, and then it'll multiply the whole thing times 30, so I need to insert my own set of parentheses for 12 times 30. And then subtract 1, and then close your bracket. So that should be my whole numerator. Yours would probably look a little bit cleaner because you guys use your alpha y equals and all that good stuff. Okay, so there's my numerator, and then I'm dividing it by, and then the fraction in the denominator, 0.05 divided by 12, gives me 832,258. Good? And we'll round to the nearest whole number. 832,259 is the nearest whole number. So what's more exciting is how much that grew over the 30 years. Yes? Okay? So if you wanted to know that, or if you were asked that, you would just find the difference, that number minus 360,000, because 360,000 is what I calculated that I put in. So you made about 472,258 free dollars. Good? I want to do something. When you gosh, I should have brought a financial statement. What do they call it? Your principal investment for this situation is pretty straightforward. Your principal investment is $12,000 per year, right? We'll let X be the number of years. Is that clear? That's your principal investment. Your annuity investment value is this formula. I'm just going to make the 30 an X. And I want to look at the principal investment and how that grows year by year versus the annuity and how that grows year by year just by kind of looking at a diagram. So give me a moment. There's 12,000 X. And here's my next one. Oh boy. I need a big set of parentheses around my numerator. 1,000 brackets, parentheses, 1 plus 0.05 divided by 12, close parentheses, raised to the 12x power, minus 1, close the bracket, close the numerator, all divided by 0.05 divided by 12. Okay, so I'm going to graph the growth of my principal and compare it to the growth of the annuity with all those percentages. So on my x-axis, what does x stand for, Bailey? In years, right? So since we're looking over the first 30 years, I'm just going to set my window from 0 to 30 years. And I'll let every hash mark be 5 years so we don't have too many of those. And then the y-axis stands for what? Olivia? the amount of money. Well, not the amount you're earning, the amount of money in each account. So this Y equals will tell us the amount in our principal investment total. And this will tell us Y equals, it's just the amount of money in whichever account, line we're looking at. So what numbers are we flirting with that would be an appropriate Y min and Y max scale? What numbers would be appropriate for the amount of money in these accounts? 0 to 1? No. 0 to what, Abby? Sure, $1 million, because we get up to 832,000. Oh, you son of a gun. Thanks for the heads up. And graph. So what you will see, and any financial advisor would kind of show you this, and why consistent contributions are good, or just, it doesn't matter. Even if you make one contribution and let it sit, exponential growth. So if you look at the first 0 to 5 years, you're not looking at much. It doesn't seem, you hear like, oh, someone just made whatever, $400,000. That's not going to happen in 5 years. This is the power of like money compounding, because that first $1,000 that you invested, that $1,000 alone got compounded 12 times, 30 times, right? It got its 5% or cut into 12 parts. Gosh, what is that? 360 times. So you made a lot of money off of that first $1,000. Let's just look at that. Your first $1,000 grew by 5%, compounded monthly, raised to and that first $1,000 was the only one that really made it through the entire 12 times 30. If we go back to this basic equation, it was compounded for 30 years, 12 times a year, so that would be 360. That first $1,000 over quadrupled in value, right? The later on investments, whatever you invested in year 28, that didn't quadruple in value because it only had 2 years to grow. So you get this benefit of time, and any financial advisor will show you this. And it's funny, my husband and I were just having this conversation last night about, the stock market had a very bad December, first of all. So he was frustrated. He's like, I feel like we should have more. I feel like this should be growing by a lot more. But what you're shown is like the over time. And so, at our age, we're only in the 5 to 10 years worth of investing range just based on our age. But when you let that money sit over time, that's what should happen. Okay? If you get into finance, and I'm just telling you this out of pure interest if you care, they'll talk a lot, though, about the power of money, right? So your initial, 360,000 growing to 832,000 over 30 years sounds awesome. Like you just made 400-some thousand. But that dollar amount of 400,000 is not nearly as strong now as it was 30 years ago. Do you know what I mean? So there's like a time-weighted perspective that they'll give you. Because $400,000 30 years ago would have bought you I don't know. What's his name? I don't know. What's our running back's name? I don't know. Our main running back on the Bills. Yeah. What about you, LaShawn McCoy's house? $400,000 would have 30 years ago. But now you probably need $3 million to do it. So there's understanding the power of money and so on and so forth. Anyway. It gets very confusing very quickly, and it gets very frustrating for a math teacher who really wants to wrap your head around everything, but I can't because it gets so complex so fast, and there's a lot of things, a lot of ways to spin it, just like we learned with statistics. But anyway, I think that number varies, but yeah, inflation in general, a loaf of bread costs $1 now, but in 30 years it'll probably cost $2. So your $400,000, you used to be able to buy 400,000 loaves of bread. Now you can only buy 200,000 loaves of bread. Do you follow? So it's not buying you as much as it used to. So there's formulas and like, you know, thought processes that try to put perspective on that, but you can't really fully wrap your head around that perspective. So they, you know, do their best to model it with like a formula to like help you understand the time weighted whatever. Anyway, I don't really know what I'm talking about. I understand generically speaking. I should have my friend who's a financial advisor listen to my explanation and see if he tells me like you're full of baloney or yeah, you're right. It's always like, yeah, you got the general idea, but every different financial advisor will even tell you like, but there's this that you got to think about. There's always another detail you could think about, but just to keep it as simplified as possible, I'm giving you the basics. Anyway, all right. This is an interesting concept. We're going to find the grand total sum of an infinite geometric series. Infinite. So if something is going to have a grand total, it almost seems like, how is that possible if the series goes on forever? Infinite, right? It doesn't ever stop. There's no last term. It goes on forever. If you look at this infinite series, what is the multiplier here? -1/2, right? 3/8 times -1/2 would give you -3/16. And then times -1/2 would give you +3/32. So what happens is, number one, if this is even going to be possible, the ratio does have to be less than 1. Because if it's growing, then there's not going to really be a cap at how big it can get. But since it's shrinking, by the time you get to your 100th term, you're essentially adding or subtracting nothing over and over again. So it gets so minuscule that it does actually tap out at a maximum, if that makes sense. Okay? So there's a formula for this. I think I wrote it on the back. The sum of an infinite geometric series, and we'll go back to the front and we'll use this, is the first term divided by 1 minus r. But it only works if the absolute value of r is less than 1. Because if you're multiplying by something that's greater than 1, or multiplying by something that's less than -1, the numbers keep growing and it won't ever like pare down to and target it on a grand total. So if you go back to the front and you do a sub 1 over 1 minus r, a sub 1 is 3/8 over 1 minus -1/2. So that's 3/8 divided by 1.5, which is 3/2. You with me there? 1 plus 1/2 is 1.5. 1.5 is 3/2. And then keep change flip. You get 2/8 or 1/4. So let me kind of show you physically how this works. So you start with 3/8, which is 0.375. Then if you add it together with the next term, how far away were we from 0.25? We were above 0.25 by 12.5%, right? 0.125. And then because we multiplied by a negative, or added a negative, we actually now are under 0.25, but not by 12.5, by 6.2.0625. You follow that? And then you add your next term. Oh geez, answer, add 3/32. And we're going to be back above 0.25, but not by much. And then subtract your next term, minus 3/64. And we're going to be back below 0.25, but not by much. And so what keeps happening is, because we're adding and subtracting less and less every time, is if this is 0.25, we were above it by a decent amount, then we were below it, then we were above it, then we were below it, and then we'll just keep doing this, and you really target in on 0.25. Do you follow that? Okay? That's it conceptually. It's really important that if R is not less than 1, or in between -1 and 1, I should say, that there will be no answer. It's not possible. But it's kind of it's a weird concept to wrap your head around, how there could be a sum of a series that's infinite. But hopefully that demonstration kind of gives you a feel for how that works. At the end of the day, you need to know how to use the formula, get an answer, and you also need to know when the formula won't be useful, which is if R is any number greater than 1 or less than -1. If you do that, you're going to get an answer, but it's not going to be right. So make sure you know when to say it's not going to work. Okie doke? So if the absolute value of R is greater than 1, then the series increases, or increases in the positive direction or increases in the negative direction, whatever, infinitely towards infinity or negative infinity. It won't zone in on a specific value. Okie doke. So this particular model had a specific place in economics. So if the government reduces taxes so that each consumer has $2,000 more income, they estimate that each person will spend 70% of it. So we all get $2,000 essentially. The government estimates that we'll all spend $1,400, right? I'll have to spend $1,400 with, let's pretend I go to a furniture store and buy an extra bonus piece of furniture. Now that furniture store has an extra $1,400, right? And they estimate that they will then spend 70% more of that. Does that make sense? And so what it does is it just kind of like flushes money through the economy, which is a good thing. People buying and selling is a good stimulus. So it kind of goes through and talks about that domino effect. It is then estimated that the business receiving this $1,400 will then spend 70% of that, which is $980. And the belief is that this trend will continue, and it's called this multiplier effect. I can't remember which Bush did this, but one of the Bushes did this to like be a stimulus on the economy, because people have more money, they're going to spend more money typically, right? They save some of it, so they put $600 in their bank account or their annuity, perhaps, but they spend $1,400 and treat themselves a little bit. So the question is, determine the total amount spent, typo, on consumer goods from the initial $2,000 tax rebate. So this essentially is an infinite series, because $2,000 was received and $1,400 of it was spent, right? And then when that $1,400 was spent, the person who received it then went and spent $980 of it. And then the person who received that $980 went and spent 70% of that, which is $686. And then someone received that. Do you see what's going on here? Okay. So this is, we're trying to figure out what is the infinite series total. How much did that giving of a $2,000, just to one person, by the way, how much did that really flush through the economy? So your series total would be your first term, which your first amount spent here, you just have to make sense of this, is $1,400. Yes? Because that $2,000 was not fully spent. Only $1,400 of it was. And then 1 minus, in our common ratio, is 0.7. So 1,400 divided by 0.3, essentially, $4,666.67. So by the time this pare down happens, 70% of 70% of 70% of 70%, just one person receiving $2,000 I mean, these are rough estimates. Not every person's going to be doing the same, but that will cost $4,666 to be flushed through the economy. Does that make sense? And you do that for millions of people, and that's a lot of money flushing through the economy and helping to spice things up. Then it hits the stock market, then people's stock market, they like to invest because they got extra money. All good things for the economy. Does anybody like economics? Yeah? I feel like economics